Okay? But it should be some review, solving proportions, and we're going to talk about similar figures, which may or may not be review, but it is something that you're definitely going to see again in geometry. So something that you might want to commit to memory and keep that with you until next year. Okay, but we're going to talk about how to solve and apply proportions, talk about scale models, if anybody's into any kind of modeling whatsoever. And then try to find missing links and of similar figures and use them to measure indirectly. Okay? All right, first and foremost, some vocabulary terms for you. You've got to remember your terminology. You've got to remember your vocabulary. Go back to your chapter 1 and 4 stuff also. And remember all of that vocabulary. You guys are going to have a semester exam, I think a 9 weeks exam, and it'll have all that stuff on it. So keep going back. Make some flashcards. Okay? And keep studying those vocabulary terms. Yes, question?
Is there a vocab quiz on the semester final?
I haven't seen it yet. My guess would be yes. There'll be vocabulary as a part of it. Okay? So, proportion is an equation that states two ratios are equal. We just talked about ratios, multiplying ratios into our converting units. Now we're going to take those two ratios and say that they're equal to each other. Right? That's what a proportion does. Similar figures are figures that have the same shape but not necessarily the same size. Okay? Their side lengths are what we call proportional, and that's why we're talking about them at the same time we talk about our proportions. It's a use for our proportions. Okay? And a scale model. A scale model is a three-dimensional model that is similar to a three-dimensional object. Scale models get used all the time in any kind of manufacturing, any kind of building, anything, whether it be architecture, okay, or any kind of design. If you're going to build a new school, to show what it's going to look like, you're not going to go and actually make the school the same size, right? You're going to make a scale model of it. But scale suggests that everything, every measure, every height, every length, every whatever is the same proportion to what the real school would look like. Okay? And then percent, you guys know this, percent out of 100. Your test scores go into Skyward as a percent. Your quizzes go in as points. So your test, we just take your points that you get and divide it by 100. Not a shocker there. Okay? All right. Proportions. How do you solve proportions? So in this first one here, 16 over 4 equals 12 over x. That is telling us those two ratios are the same. 16 over 4 and 12 over whatever x is, those are two ratios that are the exact same. They have the exact same value. We just got to figure out what x is. Okay? And to do that, we simply cross multiply. 16 times x is 16x. 4 times 12 is 48. Then divide by 16. And x is 3. Okay? That's it. You just cross multiply. You cannot, I'm going to say this, it sometimes gets me in trouble because this gives you an idea of what you think you should do, but you can't cross simplify. Okay? You can't reduce the 12 and the 4 and then decide to cross multiply. Okay? I can get you in trouble. Just cross multiply and then solve the equation that's left. Now, when you cross multiply, there's a property for proportions that says, if I multiply this diagonal, the 4 and the 12, then I should get the exact same value if I multiply the other diagonal, 16 and x. So that's why when we multiply this way, we set it equal to multiplying that way, right? We're getting an equivalent equation that gives us the same value as the solution. That's why we set them equal. So each diagonal, we're going to multiply out and set them equal to each other. Okay? Is this brand new to anybody? I think you probably have seen this before, right? So try it. Number 3. Which is weird. How about do number 2 before you do number 3? Okay, cross multiply. The property of a proportion says that if I take 5 times 3 and get 15, that should be equal to taking 2 times 3c and getting 6c. Right? And then we're just into our solving equations deal, where we're just going to divide by 6. And so c is equal to 15 over 6, or we could, of course, reduce to 5/2. Right? Anybody have issues there? Try 3 now. Okay, and we should be there. Right? Again, cross multiply. The property of proportion says if you take 5 times 9 and get 45, it should be the same thing as taking 8 times m. Those should be equal. Divide by 8, divide by 8. So m is 45 over 8, and unfortunately we cannot reduce that down anymore. So what does that mean exactly? Let me back up for a second. To here. When we cross multiply, and got x is 3. Okay? What that tells us is if I put x into here, I should get 2 ratios that are exactly the same. 16 to 4 has to equal 12 to 3. Well, if you reduce each of those ratios, which is fine now, they reduce down to 4 to 1. And so we do get 2 ratios that are equal. All right? So that's what we're doing here when we're solving a proportion. What's that? Are you going to have to do what now? It would be nice to check your answer, right? Again, it's a beautiful thing about math. It's why it's better than English and social studies and all those other topics. You can always check and make sure your answer's right before you hand your test in. Right? So I certainly would do that. If you can. I mean, some of these are end up getting you ugly type solutions. But anyway, I certainly would. Now, next one. Okay, it's the same thing. We've got 2 ratios. 6 to 3 is equal to x plus 8 to negative 1. Those are 2 ratios that are supposed to be equal. We're going to do these just like we've done every other one. But there is a hurdle here that you have to make sure you don't stumble across. We're going to cross multiply. We're going to take 6 times negative 1 and get negative 6. That's going to be equal to taking 3 times that entire numerator. 3 times all of x plus 8. Which means that we need to distribute that 3. Okay? When you cross multiply, you're taking the entire numerator from one and multiplying it by the entire denominator of the other one. So you got to multiply it across all the terms. Okay, and then you're just into your solving mode. Subtract 24. Then divide by 3. And so x is negative 10. If I were to plug this in here, right, we get 6 to 3, or that's whatever that number that is, equals negative 10 plus 8 to negative 1. So 6 to 3 has to equal negative 2 over negative 1. Reduce this to 2 over 1, to 2 to 1. Two negatives make a positive. 2 to 1. So then, yeah, that's right. X is negative 10. Okay? But just be careful there. Make sure you multiply by the entire numerator or the entire denominator, whatever the case may be. All right? Now you try. Okay? I think most of you guys have a pretty good start anyway. Right? We're going to cross multiply. Just make sure that you multiply everything together. 10 times x minus 2, all of that. 4 times x plus 10, all of that. So distribute. Okay, and then you're in your solving mode. Collect your x's, or zero out one of the x's. Zero out the 4x by subtracting 4x from it. Okay, then we're going to add 20. Because now we're trying to isolate that variable. Then divide by 6. And so x is 10. If I were to plug the 10 in for x in the original proportion, then I should get two ratios that are exactly the same. Okay, you get 8 to 4 equals 20 to 10. They're both going to reduce down to 2 to 1. So that would definitely happen. Okay? Any major issues or questions there? Cool. Try that one. All right, what you should come up with. Cross multiply. Negative 5 times 2x is negative 10x. I'm going to multiply this 6 into both of these guys and get 6x plus 24. Now, subtract 6x, subtract 6x. Divide by negative 16. Right? And you end up getting negative 3 over 2. Reduce it. Okay? Questions there? Okay? All right. So how can these help? How can these proportions help? Right? Well, we can, if we can get pretty good at setting up our own proportions, then it can help us find a missing measure. Right? So you're taking an art class, and you want to make a scale model of a clay horse you saw in a museum. Okay? Now, the actual clay horse is 1.5 meters tall and 2 meters long. Okay? And you don't want to make yours that big. You want to make a scale model. Okay? To bring it to school, you have a box that's 18 inches long. Now, to make it a scale model, you have to make sure that the ratio of the heights between the actual clay horse and your model is the same as the ratio of the lengths, right? So if I'm gonna use 18 inches, so I can put this thing in the box, how tall am I gonna have to make this horse so that it looks right, so that it looks proportional to the actual clay horse? Okay? Well, we can set up a proportion to help us figure that out. And I'll tell you this. I'll tell you the same thing I always tell geometry students. Okay? The nice thing about setting up your own proportion is there's about 15 different ways that you can set up a proportion and still get a correct measurement coming out of it. Okay? All you have to do is make sure that the two ratios that you decide to set equal to each other follow the same sort of pattern. Establish a pattern with one ratio. And when you set that second ratio equal to it, make sure the second ratio follows the same pattern, right? Doesn't matter how you choose to do it. Ratios, remember, compare to measurements. So for right now, I think it makes enough sense to compare the clay horse's height to the model's height. Just go height to height, right? And then you can compare length to length in the other ratio and set them equal to each other. Well, the length, the actual clay horse is 2 meters long. And you're going to make your model 18 inches long. So I'm going to write a ratio that compares the 2 meters to the 18 inches of the model. That's length to length. It's also clay horse length in the numerator and model length in the denominator. I want my next ratio to follow the exact same pattern.
So it would be 1.5 over,
Which we don't know. We don't know the height of our model, right?
yeah.
So let it be x. Where x is going to be the height of the model. Okay? So we went length to length equals height to height, and we did clay horse to model equals clay horse to model. So as long as your ratios follow the same pattern, you're going to be fine. And there's a bunch of other patterns out there. Right, Isaac? You don't need that. Okay? Now to find out how tall your model needs to be, we're just going to cross multiply. 2x equals 1.5 times 18, which is 27, divided by 2. So x is 13.5. Now the height of the model suggests that we need to include units here. This is going to be 13.5 inches. Okay? So you need to make sure that your model is 13.5 inches tall. All right? I always say this too. Because of the flexibility of proportions, you've got to try pretty hard to screw them up. Some of you guys will try hard enough. Okay? That's okay. We'll fix them and move on. All right? So that's one use of our proportions. Another is when we start talking about similar figures. Okay? Again, similar figures are figures that have the same shape, but not necessarily the same size, like these two triangles right here. These two triangles are similar. And so we talk about triangle ABC being similar to triangle XYZ. Well, you'll get into that a whole lot more when you're taking geometry. Because of that, we know that the side lengths are what we call proportional. Means if you compare the corresponding side lengths to each other, they should be in the same ratio. If they're in the same ratio, then you can set up a proportion to find missing sides if you need to. Now, which sides are corresponding? Very often you're going to be able to tell by looking at the picture. Okay, but if you can't, this is what's called a similarity statement, and it's going to tell you which sides are corresponding, which sides should go together, which sides should match. Okay? So this says that if I take the length of AB in this triangle and compare it to the length of XY in the other triangle, it should be the same as the ratio of, well, BC to YZ. Everything matches up in the statement. That ratio should be the same as if I compare AC to XZ. If that's the case, then you plug in the lengths that you know, right? Grab two of those ratios and figure out which one's going to help you solve for what you're missing. In other words, I could take AB, which is 6, and compare it to XY, which is 9. And that ratio should be equal to taking BC, which is 8, and comparing it to YZ, which is 12. And if you reduce both of those down, you get 2 to 3. So those two ratios are the same. Okay, what should also be equal to the ratio of AC, which is 10, to the ratio to the measure of AC, which is 10, and the measure of XZ, which we don't know right now. So let it be X. So what we can do then is just grab a part of this and make that the proportion that you want to solve. So take 8 to 12, set it equal to 10 to x, cross multiply and solve, right? Which we can't see, so I'm going to move it over here. 8x equals 120. Now divide by 8. And x ends up being 15. That means that the missing length right here is 15. Does that make sense? Make enough sense? Okay. And for number 9, okay, we have the same two triangles. Those two triangles are similar. That tells us that the following ratios are all equal. AB to XY, BC to YZ, and AC to XZ. Use those to help find the missing sides. Okay? I'll leave that for you to think about for just a couple of seconds. We're getting there. So we have our ratios that should be equal. So now just plug in what you know, right? AB is 4. XY is, well, I don't know. So let it be X. BC is 3. YZ is, well, I don't know. You really ought to let it be another variable. So Y. I saw a lot of you guys using X twice, and if you can keep them straight, then you're okay, but mathematically speaking, you really ought to use a different variable. But we're figuring this stuff out, so I'm okay right now if you're going to use X for both. And then AC over XZ is 5 to 10. Now, what should make sense, hopefully, is that you grab two ratios that you can actually use to solve for one of your variables. So 3 to Y equals 5 to 10. Cross, multiply, and solve, and you get 5Y equals 30. And so Y is 6. Right? Now, I want to take 4 to X and set it equal to 5 to 10. Cross multiply, get 5x equals 40, and therefore x is 8. Okay, so our two missing side lengths are 8 and 6. Okay?
So you just use the one that's like 5 in.
Yeah, otherwise, if you try to set 4 to x equal to 3 to y, you're going to have two variables. You won't be able to solve it, right?
Yeah, that's what I was confused about.
Yeah, right. So use the ratio that gives you two more numerical values, actual lengths, and then you can actually solve the proportion that way. Okay? Make sense? Awesome. I'm going to let you try this all on your own. Those two shapes are similar. Go find x. All right? So, following shapes are similar, find x. Typically, what we try to do is match up the sides that correspond between our two similar figures, right? This figure is similar to this one, and so I want to take, when I write a ratio, I want to compare the sides that match up between the two shapes. The side that is 18 here matches up with which side in the bigger guy? The 30. So I would write 18 to 30 and set it equal to the other two corresponding sides that I have, which is 39 to the x. Okay? Now, that being said, a couple of you guys wanted to do 30 to x has to equal 18 to 39, and that's fine. As long as your ratios go the same way, follow the same pattern. You went side to this, what we could call the base, I guess, and then side to the base. Okay? That works. That works. Right? So now we're going to just cross, multiply, and solve. Because when you guys, those of you that did it differently, when you cross, multiply, you're going to end up with the same equation. 18x equals 1170. Is that right? Then divide by 18, and x is 65. Thank you. So then that base length of the bigger, what would be a trapezoid probably, is 65. Okay? Issues, questions there? Okay. One more guy to talk about. We're all done. The student who is 5.25 feet tall is standing next to a tree. The shadow of the student is 20 feet, and the shadow of the tree is 80 feet. What's the height of the tree? Right? You ever want to know how tall a tree is? You can do this. There's an even better way to do this, but we'll work with the problem that we have. All right? So, every good story problem, right, or at least a very good strategy to work a story problem is to draw a picture. Right? So I need someone who is 5.2 feet tall. Okay, with a really long arm. 5.25 feet tall. Standing next to, well, the shadow here, right? So the sun's going to hit the top of his head. Okay, he's going to cast a shadow 20 feet long. He's standing next to a tree. We don't know how tall that tree is, but it's casting a shadow 80 feet long. Okay? Without going into too much geometry, right? We've got two right triangles, basically. A tree typically grows perpendicular to the ground. When we talk about your height, we talk about it being perpendicular to the ground, right? Not very many of you guys go to the doctor and lean to one side and say, how tall am I? Right? You're standing straight up where you're perpendicular. Okay? So we've got two pictures here. We've got two triangles that are going to be similar. Okay? So we can use the idea of setting up a proportion between our matching sides to find out how tall that tree is. The height of the student can be compared to the height of the tree. And then the shadow of the student can be compared to the shadow of the tree. And now you can cross multiply and solve. 20x, right? Now we got to do 5.25 times 80. What is it, 420? Then divide by 20. X is 21. So how tall is the tree? The tree is 21 feet tall. Which again, you'd be able to see if that trial thing would go away. Does that make sense? Okay? All right.